Which of the following correctly describes a product and gives the appropriate supporting example? A, the product is always rational. So we have the square root of 3, radical 3 times radical 3, radical 9, which equals 3. Radical 4 times radical 1 gives me radical 4, which gives me 2. Those are both rational, but let's keep looking and see. So let's just think about this. So these are two irrational numbers. Let's just say I do square root of 3 times square root of 2. That gives me square root of 6, which is not rational. So that disproves A. Alright, the product is always irrational. Well, right here we got square root of 5 times square root of 2, square root of 10. And that one's irrational. Square root of 8. And we got, now right here we're going to have two irrationals and we have two irrationals. Alright, so right here we're going to have square root of 16 is 4. So that disproves it. So we have a rational and an irrational. Alright. C, the product may either be rational or irrational. So square root of 2 times square root of 3 is square root of 6. That's irrational. Square root of 12 times square root of 3 is square root of 36, which is 6. It's rational. So my answer is C. And then the bottom doesn't make any sense because it's got to be either rational or irrational. It can't be neither. Alright. Look at this expression. 2 on radical 8 times radical 20. Which of the following is equivalent to this expression? So 2 on the square root of 8. 4 on the radical of 2. Radical of 4 gives me 2. 4 on the radical of 2. 20 is 5 times 4. Alright, gives me 2 on the radical of 5. 4 times 2 is 8. 5 times 2 is 10. Alright, so I got 8 on the radical of 10. Which is 8 on the radical of 10. Which sum is rational? So we have pi plus square root of 18. This is a rational number. Plus a rational number, that's going to be irrational. Alright. Square root of 25 plus 1.75. It's going to be 5 plus 1.75, which will be 6.75, which is rational. Square root of 3 is irrational. So this will be irrational. Pi is irrational. And radical 2 is irrational, which will be irrational. Alright, right here. Which product is irrational? Square root of 50 times 2, which gives me square root of 100 equals 10. Square root of 64 times the square root of 4. Square root of 64 is 8. Square root of 4, which is 2, gives me 16. Square root of 9 is 3, times the square root of 49 is 7, which gives me 21. So by process of elimination, we know it has to be this one, which gives me the square root of 80. And if we simplify the square root of 80, we're going to get 16 times 5, which is 4 on the radical of 5, which is a rational number. Okay? Tell me if it's rational or irrational, and simplify. So, radical 8, if I simplify that, 4, 2, 2 on the radical of 2, which is irrational. The next one, radical 49 is 7. 7 plus 2 is 9. Radical 9 equals 3. That is rational. This one, 27, 9 and 3. down to 2. 3 times 2. Minus 1 radical 3. 25 radical 3. Square root of 25. Times negative 1. So 6 minus 1 gives me 5 radical 3, which in turn gives me 0, which is rational. 12, radical 12 times radical 3, that gives me radical 36, which is 6, which is rational. Pi, 1, 4, ... which is irrational. Non-terminating, non-repeating decimal. Going to be irrational. Right here, multiplying them together. We're going to simplify first, so we can simplify at the end. So we have 9 and 2. Alright, we got 8 to the 5th. Okay, so that's going to be 5a's. Square root of 9 is 3, comes out. Pair of a's, pair of a's. Gives me a squared on the outside. We got 2a inside. 6 on the radical of a. We got 4a, so we know this is squared. Square root, so that's going to be 2a's go on the outside, so that's going to be times a squared, radical of 6. I multiply the outside. I got 3, a to the 4th, because a squared times a squared. A2 plus 2, which is a to the 4th. And then 2a times 6 is going to give me 12a. This is going to be irrational. Down here at the bottom, multiplying. So I'm going to distribute 6 times 4a. 6a times 4a gives me, I could do 24a. Or since 4 is a perfect square, gives me 2 on the outside, so I can just do 3 times 2. That makes that a 1. 6. 6a times a is going to be 6a squared, which in turn, a squared, I have 2a's, pulls a out, so that gives me 6. A on the radical of 6. Multiply the next one. Three times 2, 6a times 15a squared. Alright, I can go ahead and pull out that a. So there's 2 of them, so I get 2a. So it's really 3 times 2a, which is going to give me 6a. And then I got 6a times 15, which is going to give me 15 times 6. 90. A. I have to simplify 90. Go to 90, 10, and 9. Greater than 9. 9 times 6a, which is going to give me 54a. So my final solution will be 6a on the radical of 6 plus 54a radical of 10a. Alright. And then the one at the top here, 6x times 12x. I'm going to simplify this. 4 and 3. Radical 4 is 2. 2 on the radical of 3x. Alright, so 6x times 3x. 2 times 1. 2 radical 18x squared. I got 2 x's, bring one out. We can do that in just a second. So I got 9 times 2 times x. Square root of 9 is 3. 2 x's, bring one out. So I end up with final solution will be 6x radical of 2, which is irrational. Alright. Right here, which of the following statements is true about the sum of rational and irrational number? The sum of rational and irrational number is always an irrational number. The sum of a rational and irrational number is never an irrational number. The sum of a rational and irrational number is sometimes rational. The sum of a rational and irrational number is always a rational number. The choice answer is A. Radical 2 plus 5 would be a non-terminating, non-repeating decimal. So it'll be something around 6.12 ... Now that might not be exact, but it's going to be a non-terminating, non-repeating decimal. Alright, which of the following is an irrational number? Square root of 36 is 6. 3.8 is a decimal. 3 over 13 is a fraction. Square root of 18 simplifies to 3 on the radical of 2, which is irrational. D. Does the set of numbers below contain rational, irrational, or both rational and irrational? We have 22, which is rational. 39 over 9, which is a fraction, is rational. 100, square root of 100, which is 10, which is rational. And terminating decimal, so they're all rational.